Welcome once again to the new video. It consists of some problems related to traces of lines. And of course it is continuation from last session. That is projection of lines inclined to both planes HP and VP. In the last video we have discussed about the traces. You should understand and make thorough with this projection on traces points. Here A dash B dash is the front view, AB is the top view of a line AB. To get the HT and VT, this is the procedure. Produce the front view A dash B dash to meet the XY line at point H dash. Draw a vertical line at H dash. To that point, produce the top view AB to meet at point HT, which gives the horizontal trace. Similarly, produce the top view AB to meet the XY line at V. Draw a vertical line at V. To that line, produce the top view of the line A dash B dash, and the meeting point is VT or VT dash. So HT is the horizontal trace. It is the point at which the line inclined to HP touches the horizontal plane, and VT or VT dash is the point at which the inclined plane, the plane inclined to VP, touches the vertical plane. So there is HT and VT. Here onwards we do some problems related to HT and VT. Front view of line AB makes 45-degree angle with XY line and measures 60 mm. Line's top view makes 30-degree with XY line. End A is 15 mm above HP and its vertical trace is 10 mm below HP. Draw the projections of line AB. Determine inclination with HP and VP and locate its traces, horizontal trace and vertical trace. These are the steps. Let us see how it is drawn. Draw the XY line first. Draw a vertical line. A dash is 15 mm above XY line. Its angle is given as 45 degree. Mark 45 degree. And the length of line is also given as 60 mm. Measure 60 mm. It is also drawn here. So we get the point B dash, which is the required front view of the line A dash B dash. It is also given that vertical trace is 10 mm below HP. So this is the locus of the vertical trace, 10 mm below XY line. To get the vertical trace, produce the front view A dash B dash, which meets the XY line at the point H dash and cuts this point at VT or VT dash. Please note that A dash B dash, H dash and VT dash or VT are on a single straight line. Draw a vertical line upwards to meet the XY line, and that point is V. That is the top view of the vertical trace. So now the 30-degree angle. The top view makes 30 degree with XY line. It is given as like this. So from point V, we can draw a 30-degree angle. And we get a line here. And of course, A will be below A dash and point B will be below B dash. A, B. Join the point AB. Now draw the locus of both B dash and B. HT is here below H dash. Draw the locus of point B. And B dash. Now rotate the end B about the point A. We get the point B1 here and produce it to the locus, or project it upwards to the locus of B dash. We get B1 dash. Join A dash B1 dash, and this is the true length of the line, and we get the inclination of the line with HP, that is theta. Take this distance on a compass and cut it on the locus of B. We get B2 as well, and this angle is phi, which is the inclination of the line with the vertical plane. It can also be drawn by rotating B dash about the point A dash, and we get a point here B2 dash. Then drop it downwards to get B2. That way also can be drawn. Another problem. One end of line AB is 10 millimeter above HP and other end is 100 millimeter in front of VP. Its front view is 45 degree inclined to XY line, while its HT and VT are 45 millimeter and 30 millimeter below XY line respectively. Draw projections and find the true length, its inclination with HP and VP. These are the steps. Let us see how it is drawn. Draw the XY line first. Draw one projector. One end of a line AB, that is point A, is given as 10 millimeter above HP. So this is the locus of A dash, and its angle is given 45 degree inclined to XY line. But the length of this line is not given, so we cannot locate B dash here. 45 degree angle. It is also given that the VT is 30 millimeter below and HT is 45 millimeter below the XY line. So this is the locus of VT and this is the locus of HT. By producing the line A dash backwards, we get H dash, that is the point at which the line cut the XY line, and this point is PT dash or VT. Draw a vertical line at VT dash, we get the point V. Now the locus of another point B is given as in front of 100 millimeter in front of VP. You can draw it as well. HT will be below H dash. So the locus of B or B2 will be 100 millimeter below XY line. Now we can join V and HT and produce it to meet this line, the locus of V, B and B2. So below A dash we get A, and this point is B dash. So above this we get B dash as well. So this point is B, and above this we get B dash. So these points are A, B. A dash will be above A and B dash will be above P. So this is the top view of the line and this is the front view of the line. To get the angle of inclination of the line with HP and VP, you have to draw the locus of A dash and A, locus of B dash and B. Now rotating the point B about the point A, we get B2 here, we get B1 here, and it is produced to the locus of B dash, we get B1 dash, join A dash B1 dash. So this is the true length of the line, and this angle gives the angle of inclination of the line with HP, theta. Similarly, we can rotate B dash about the point A dash. This point is B2 dash and drop it downwards to get B2. Join A B2, which is also true length. Otherwise, we can take this measurement on a compass and find this point B2, and this angle is phi, which is the angle of inclination of the line with the vertical plane, VP. This is the method of finding the projections from the traces. The last problem. Projectors drawn from HT and VT of a line AB are 80 millimeter apart, and those from its ends are 50 millimeter apart. That is, A dash A, B dash B are the end projectors. 50 is the distance between the end projectors, and 80 is the distance between two traces, vertical trace and horizontal trace. End A is 10 millimeter above HP. HT is 35 millimeter in front of VP, while its VT is 45 millimeter above HP. Draw projections, locate the traces, find true length of line and inclinations with HP and VP. Here is the solution for this. Draw the XY line first. Now two lines about 80 millimeter apart. This is the distance between the projectors from HT and VT. So HT and VT will be in these lines. It is also given that HT is 35 millimeter in front of VP. So it will be 35 millimeter below XY line, and VT is 45 millimeter above HP. So it will be 45 millimeter above XY line. Now we can draw the front view of the line joining VT to H dash. And joining HT to V, we get another line. The end A dash, or the location of A dash, can be found out by the end A is 10 millimeter above HP. So it is the locus of A dash. By drawing this, we can find A dash. It is also given that end projectors are at a distance of 50 millimeter apart. So from here, draw a 50 millimeter line at a distance of 50 millimeter from A dash. So here we get B dash. Join A dash B dash. That is the front view of the line. And here is A. Of course, B will be here. Join AB as well. That is the top view. Now draw the locus of A as well. B, B dash and B. By rotating the ends B dash and B, we can find the true length of the lines and inclination with HP and BP. So B is rotated to the locus of A. This point is B1 and it is projected upwards to the locus of B dash. We get B1 dash. Join A dash B1 dash. We get the angle theta, or it is the inclination of the line with HP and the true length. Take the true length A dash B1 dash and cut it on the locus of B, we get B2. So this is the angle of inclination of the line with VP. This is also the true length. Thank you.